Hi everyone, once again welcome to this LPS course. We will be continuing our lecture on TK. We finished talking about tickle. I hope you have all the things well understood now. Now we will talk about TK. Actually, we are actually discussing TK for the last two lectures. Today we will be continuing that. But before we go into like today's topics itself, I'm going to give you a brief overview of what we talked about. Some of the things may not be very clear in the last couple of lectures, but I'm going to see how I can clarify those points. So let's do a recap. So mainly like we talked about the TK fundamentals. The GUI essentially GUI fundamentals actually is basically there is concept of event. The event is any operation or movement using mouse or keypad. Nowadays even like the finger movements on touch screen, things like that are also like you can call it as an event. But traditionally what we meant was whenever the mouse moves, like I don't know whether you can see that there is a dot moving over, or some kind of keypad press is an event on a window. And then the move itself, you can say that it's moving the mouse from one point to another point, that it constitutes a move. And then the key press is basically like depressing any key, either the mouse keys, the particular one like the right click, left click, or middle click, or a key on the keyboard. You can also add additional stuff like the rolling of the mouse, things like that. So the main thing that we will be talking about in TK is how do we develop applications that can capture these GUI interface and work with them to achieve whatever that you want to actually run or execute a particular command. So the other concept is also regarding the windows. The window is any specific area of the terminal. Usually it's a rectangle and it is bounded by a frame. So we will talk. We'll see what is the thing. And then widget is the other concept, which is part of the window that does a specific task. Basically, it has a shape and it does a specific task. So these are the 2 points that you want to understand basically regarding widget. In most of the textbooks and things like that, they use window and widget as synonyms. But in this class, I want to separate this out, and basically, a window is a collection of widgets, and how we will define it, we will see basically. And then most of the things that we will be worrying about is regarding the widgets and how do we enable the widgets and how do we work with widgets, how do we assign commands to widgets, how do we create widgets, things like that. That's all covered under this TK or toolkit. So here is a brief look at the concept. So you can think of this entire region being a window. Okay. So the window includes, actually if you look at it, there are 4 widgets as such. So there is a frame which is probably the widget number 1, no actually the widget number 0, and then you have actually this should be widget number 3, and then you have this portion of this window, which is itself is a widget that we call it as widget number 1. We will see, like, I mean, we have already seen like how these things are defined, but anyway, and then there is another piece here which is also embedded here, that's widget number 2, and then the third piece which is basically like gives you all the directory names, and then this is widget number 3. In fact, you can also think of this structure here as another widget 4. So altogether now you get like actually 5 widgets in this particular window. So remember this concept. We will come back to this essentially, like, I mean, so, and each one has a different function as I mentioned. So for example, this one is what is called the banner widget. It just displays the banner. The frame widget essentially like outlines the frame, and then this is the menu widget which contains like what are the menus, different menus. Here it's file and help, and then the main display widget which is this one, plus there is a menu bar widget which is essentially make sure that this scroll bar can move up and down. Okay, so that's the basic concept of Windows and widgets. So in a sense, widgets are objects instances of classes. So now we are introducing a new term called classes that represent buttons, frames, and so on. So if you look at here, actually this could be, we can make this as a button, and we know already that there is a frame here. Okay. So the first thing you will need to identify need to do is to identify the specific class of widget that you would like to instantiate. So for every class of widget we have an equivalent command which we will talk about it little later. In fact, we covered this in I think lecture number 2 or lecture number 1 rather. So classes are important because they determine the precedence if there are multiple bindings to a single event. So what are these bindings? Essentially the bindings are essentially like, I mean, once you have an event you can trap that event and then you can make the widgets perform certain functions based on that event. The event could be like a key press or even moving, whatever it is. Basically like you can make it perform certain things. And to determine like, I mean, how these go when there are multiple widgets involved, the class actually can be one of the determining factors. So we will see like whether we want to do. And by the way, the multiple bindings are legal and will result in multiple outputs, which is also pretty much okay. For example, here there's a cursor move from one place to another place can cause a Windows to become active, as well as some command that may start running within that window. So both of them are simultaneously having activated, and both of them are running simultaneously, which is perfectly okay. Sometimes we want to be specific, so this is again something that we covered in the last lecture. And then couple of other points to note is the widget command itself is deleted when the widget is destroyed. So any command associated with the widgets are all like completely gone. So where is this command? What is this command? That's also we covered, but I will talk about it in the next slide. And then one thing to note is the state of the element of the widget, or the state of the particular window. It should be readable, modifiable at any time. This is the principle that we operate with within this framework. So again, like what is a state? State is basically like once you get an event, how do you respond to it, and that is the state. And then that state is essentially what we will be talking about. So like the structure of the TK application, we talked about this, basically the widget hierarchy, which I will cover once again. And then there is one tickle interpreter which basically interprets all the tickle coding underneath these widgets, and there is just one process. You can have more than one application in that process, but it's only one process in per ticket. And then we already talked about the widget. Basically again, widget and Windows are synonyms kind of most of the cases. We will say like, I mean, basically it is even though it says particular look and feel, it's basically we define very strictly as it has a widget is has physical shape and it has a single purpose. Okay, I mean this is the same thing that I talked about here, shape and a task. Okay, so I'll just add this thing, physical shape and then a singular purpose. So widget classes implemented are these ones. I will also like cover some of this in the next slide too. But you can think of this as frame. label, button, check button, radio button, menu button. Even in button has like so many different classes, and we have menu as another one, message, entry, text, canvas, scroll bar, scale, list box, and top level. So we will be talking about some of these things. Basically, I think like text we will talk about. We will talk about canvas, what canvas is. We already talked about frames and buttons. Other things like the menu button and things like that are specialized items of these buttons themselves. So you can actually look it up on those things. And then we'll also probably cover the top level too. So let's see. How do we create a Windows or create a widget essentially, or basically an application? So we need to create the main window using the WM command, and then the top level. Actually, like there is also a top level, a command called top level to create the top level window. Then we define widgets within that window. Again, for this, I want you to remember the widget hierarchy where we started with the dot and then went into multiple dot txt or dot frame, things like that. Basically, like there's a whole bunch of these hierarchies that we talked about. So remember that basically, and then that's how we are defining. And the way that we define is we start defining widgets one at a time. So here saying that frame is another one widget basically with a size, and then we can use pack, place. These are all like command names actually. So we can do that, and then we can also create other classes of widgets, whether within that hierarchy or at the top level, whichever one based on the application needs. We create these other widgets which are buttons, dialog box, etc. And then we define the commands that can be run on these widgets using the dash command option. Okay, so this is something that we talked about. And then we also bind events to commands using the bind command. So the events are again like those key presses and things like that. So we can call this button, but basically like maybe say run, and then this run gets activated only if the key is pressed on top of that run. So that is the event that we trap, and then basically we run particular command, and then that is denoted by this bind command. And then once we do this and we create this the graphical picture as to how this application looks like, and then we go ahead and define all the procs within whatever we are coming up with inside this the graphical picture. So all of them we have to define which are declared in all the previous sections. So with that actually like we saw some examples, but let's see, like I mean, so the top level widget is again that dot, and any other widget is defined as hierarchically from that dot. So dot and then x, a, under x you have y, under y you have actually like under x you have no, yeah, but like this, then you have z, and then under a you have y, which is not the same as x dot y. It's x dot a dot y. Here x dot a dot z is one particular widget. And then how do we configure widgets? This is another thing that we saw. This is using the config command or configure command. So the beauty of this command is it's the same command that is also you can use it to query a particular configuration. For example, here as you know, like I'm in window is .x, and we give this config command and then say like background make it red. So now the command goes and actually like configures this particular window with the background color as X. So now if we omit this red and then just give X config dash background, that returns this string, and you can say that basically like this is the background, and then that is set to background because so dash background, and then actually the background color is determined by FFE4 C4 in hex or in and then it's actually red, the actual color red. So it gives you like all these information. One thing we notice, you know what, I can query these, but you know these things are just noise. I don't want to do any of these. I only want to know what is the background color, and I want to know just red. So how do we do it? So here there is one additional function that got defined, which is actually it's a synonym for config get called cget, and the cget basically when you give that command with .x and what is the option, which is background, you directly get just x, just red. So it's a very handy command called cget. So keep that in mind. And then we can actually, in fact, if the window is already configured, we can actually change the existing configuration of the widgets using config command. So again, some of the popular classes of commands, also the objects essentially in the Windows: button, radio button, menu, canvas, frame, text, list box. Now I also talked about tags essentially. The tags are objects associated with the text widget essentially, and then each tag is referred to via a name chosen by the programmer. Each tag can have a number of different configuration options. The things like fonts, colors, etc. that will be used to format text can be put in as a tag. Even though like the tags themselves are objects having a state, they don't need to be explicitly created. They will be automatically created the first time when the tag name is used. Okay, so here .text for example, and then the tag is configure highlight line background yellow font and relief raised. Basically it does that to the text window as defined in this command. Then we also talked about this binding order essentially, which is what if multiple bindings match an event. As I mentioned, everything goes in parallel, but we can make it most specific, which is one binding triggers per tag, and it follows the default order of the tags, which is like widget, class, top level, and then all. But we can change the tags with the bind tags command. So again, we can also like bind a particular tag to a particular window. So one thing we notice here is like just the general tag is associated with the text for using these highlights and things like that. But in general, any tag can be bound to a particular window and reclassify that window into a different one. Okay, so here like we can say like bind tags dot be my button, and then we can also say that it is bound to this particular actually like so this is who all. So that's what we are doing the bind tags for, and we can also like if you want to skip a particular tag, we can just say break, and then that can actually skip some later tags as well. I'm going to refer to the textbook for the exact definition of the bind the tags. essentially like it's a widget class name, basically like a button or whatever it is, and then um, so that's where it is bound to. Okay, so that's what we covered in the last lecture. Today we will talk about some new topics in the TK class basically, and again we will use some examples to illustrate how TK works for these ones. So here is an example for a calendar, or it's called TK Cal. Okay, so we first initialize the global variables, which are basically months, January, February, all the months of the year. Then we can execute this command called date. The date actually returns this whatever this particular string, which is like the day, the month, the date, and then the time zone, and then the year. So we take the month as the index 1 of this string. Can anyone tell me, like, I mean, why this is 1? Actually, this string starts from 0, so this is 1. And then the index for index number 5 denotes the year. So again we count here from here. This the exact date is actually 2. This entire thing is 3. This is 4, and this is 5. So now we get like month and the year. Now we can expand the abbreviation that date gave us basically for. So now we can say that basically in this loop we can set we can find out, like, I mean, which month it is. So basically like run it through this, and then essentially like we are seeing whether there is a match for any particular month that we got here in this one. So the way that we are doing it is essentially like a string match, where we do like dollar month, because we can go with the whatever, like this particular month that we read in with all these things, and we just do a string match. And when we do this multiplication, actually we know that actually whether this can result in a 0 or 1 based on whether it is matching or not. When it's matching, we capture that, and then we we break the loop. So here we define some menus, the menu action basically, which is called a do menu. That is what we are defining, which is we just set the month to $m, and this is the global month essentially. And then we basically configure these windows, essentially .f.mv, and then we configure with that particular month. So now this will generate here this number, and possibly this year. Now we need to generate the calendar output. So we can run this program called cal and then collect its output. So to show calendar, that is the next prog that we are going to write, which is having the global as month, year, and months, which is passed from the top level into this program, as you know, which is already set all these things. So now we do a list search of the months with the month itself, and then we make it +1 essentially. So this will give you the index +1, which is essentially like the actual month representation. So as you know here, this index actually is 0, 1, 2, 3, but in reality January is 1, 2, 3, 4. April is 3, 4, right? So we need to add that from that index so that we get the actual month, and then we use the cal program where we pass the cal this month, the number of the month, and then the year, and then we basically get the whatever the result is. And then here, like we just define some error conditions also, just to make sure that it doesn't error out. And now for the same window, essentially like where it's a text box window, we will talk about that in the next one. We delete and then insert the output of the cal, which is right here. Essentially, like set cal is here. Only when it's index, when there's an error, it is set to error. But otherwise, it will set to the calendar from the cal function. Now we set up the top widgets. Basically, we set up the frame, and then we pack how to define that, and then we have a menu button, and then that is the .mv. So here it's the same thing. So that it is configured as the month, but we have another menu item which is defined as a window under this MB, which is called the M, and then that has a width of 12, and we just pack that towards the left. Now how do we populate this one? That's for essentially like we say like for each month in M, basically then we add a command to get the label and put it in. So now we have, if you look at this picture, we have this is already set. Now we need to get to the date, and then we can see the calendar. So now for the year, again we essentially like we have a variable called year, and with this 5, and then basically like that's where we can enter the year, and then we do similar kind of things. Basically we set up a button called see calendar, that's this button here, see calendar. And then that also has a text width and various parameters there. So this is the text command, which is a text window, and then we pack basically, and then we say the initial display is show calendar. Okay, so this is one full example of a typical calendar or a TK calendar. I think like you can try this out first in your free time, and then see how it works, and then pretty much then it will become self-explanatory. So a few more things. Basically this is something that we already talked about, the cget widget. Essentially like we say like cget foreground, it just gives the black. Again as I said earlier, it's very easy, much more easier than doing www configure and dash foreground. This gives all kinds of junk, right? We don't need this. Now the as similar to Perl, the env array contains the environment variables. So env home, env editor, things like that. So you have like multi-line area text area widget. Essentially, like I mean that the text widget essentially. The text widget is essentially a multi-line text area widget with a number of features, essentially 1001 features. You can do editing and you can use Emacs key bindings. You can do scrolling from manual and from code, X and Y axis, and it has a flexible text formatting, multiple fonts and multiple colors are supported. Text tags that we talked about earlier, and then also selection manipulation. Selection is something, one command that we talked about in the last class. I will explain some more either in this class or later on. And it also arranges text and embedded widgets in lines. The lines can wrap but cannot flow. So what are some special widget commands? Set, get, delete, select, mark, tag, search, see, window, Y view, X view, bind. These are all special widget commands for the text widget. And then the configuration options, we have a state that we can define, height and width, the spacing 1, spacing 2 and spacing 3, and then what are the state tabs, and then we can say like insert background and or select background. So the text that is there inside the text widget has these following things. One is called index, which is essentially like a line dot character. So if you have like 5 lines, and then say like I mean line starts at 1 and character starts at 0. So this is counted as 1, 2, 3, 4, 5, and then this is 0 through whatever, say 18. And then now you can actually go exactly to say 53, and then you can read out this number of characters. And then you can also do mark, basically a name for an index essentially. So you can say like I mean T mark set my place 6.23. So it will exactly like do that. And then tag is also like I mean you can use tag to find the ranges of text. For example, you can say like T tag add my words 6.23, 6.30. So it will go to the specific location and then perform this function, which is called the add. And then same thing with the other. So this tags will be very useful as we will see more and more. And as I said, basically the tag is one thing, like I mean it's not a permanent command. Basically the state is saved. So a tagged text can also be configured, and we can use configure command to configure the tag text. And then the tag text can also have bindings. We can bind certain keystrokes to that particular command, and then we can call it to execute certain things. And then usually the text widgets can serve as the geometry managers for other widgets. So here is one quick example essentially, which is using also this new command called image. So using the image, we create a photo and a dash file called bar.gif, which is this one. Now we say basically like t.l image1, and then t window create 1.5 to t1, and then that brings up this window here. So then now we come to the syntax coloring mini editor. So the TK Emacs does not customize syntax coloring using the regular expressions like Emacs Highlight 9 package. It still has one text widget, one scroll widget, and can read and save files. About 100 lines of well commented code is available through this through this program. So we come to TK Emacs, basically like for all machines routine. So here also like we see basically like for all matches, we give a pattern and a script with the W option. So first of all, we determine the number of lines in the widget, which is scan in W through end, and if you count the number of lines, it has some value basically. And then for every line, we increment the line, and then basically we and do a using regular expression, we kind of find what is there, and then basically like we generate that as a mark set command, and then we pass it down and then move on. And here is the do colors routine essentially, like which is for all the array names and for all the syntax pattern arrays called name, we go ahead and delete the tag and then basically do the tag first last basically. Okay, and now we load that file. For loading the file, essentially we call the file and then we set the file as file open, and then we just want to insert that particular variable. And then the write file is essentially like we open the file and then basically just write it. So here we define all the colors and basically all the form that we wanted. Okay, so continuing with the text widget, the tag text can be configured. So that is using this .t tag configure my words foreground red. And then the tagged text can have bindings essentially. So if you have a text like this, it can actually bound to the my word list. So it need not you don't have to do it explicitly. And then the text widgets can serve as geometry managers for other widgets. We'll also see this basically how this works. And then the syntax coloring mini editor, the TK Emacs does customize does customizable syntax using coloring of using regular expressions like Emacs highlight 19 package. It's one text widget, one scroll widget, one read and write save files, and then about 100 lines of well documented code. So what is the rationale behind this TK Emacs? So here is another one the for all matches routine. So here we define that for all matches W pattern script, and then we do a scan basically like to see whether that exists. Here we just calculate the number of lines essentially. And then in this loop essentially we get the end and then we add that one factor to it. And then the do color routine basically it's does the coloring. Here we specify like for each of the arrays. You also specify the syntax pattern, and then we basically we can go ahead and delete the tag itself. And then we configure with some configuration values. So the do color routine essentially is the same. If it works the same way, basically like we delete that particular file and then we say like set a file open to the dollar file, and then until the end of line end of file for $f, the $w insert and insert end, and then so that will be the read of 1000 lines. And then the write file, same thing. Basically we do the opposite, which is basically write file W file, and then we do F open log dollar file with the W permission. So here you see basically it's only just open file. And then we basically whatever we collect in that window, we just say puts and then the $w, and then we just close that file. So we take a look at some of the Emacs how it behaves in terms of other things. So one is the set syntax pattern or types, which is gets all the alphanumeric characters, and then set syntax colors types yellow, that checks for that. Syntax pattern directives, again various directives are there. Syntax colors or directives and purple that's another thing. Then the syntax patterns for new line types essentially, and then for that we cut the. So here essentially like we can see that once we have the syntax patterns as new line, so syntax pattern new line types essentially has all these various types, whether it's character, it's a short or integer, long, unsigned, signed, float, and double. Then we declare the color essentially as yellow, and then the syntax pattern is the regular alphanumeric, and then if all these are commands also, and then following the commands again it's alphanumeric. And then we also specifically look for certain syntax patterns, which is star dot star here. So this is one thing. So now we actually it comes to setting up. So in this one actually we are reversing the process a little bit. So in the previous example I mentioned that actually we do all the frame and build all the GUI and then go back and fill up the procs. In this one we actually like did all the procs upfront, and then now we are going to do the Windows itself. So here we set up the widgets. Basically we call it text widget .t, and then basically we give several other things. The Y scroll command, insert background, and width and height. So we specify all these things and then we pack it, and then we adjust from the left side, and then we just expand it to fill essentially. And then we also give some configuration items. So we configure as tabs 32, 64, 96, and then configure background is black and then foreground is white. So we'll come to see like why we need these things shortly. And then we also generate a scroll bar, and then that's on the Y side. And then we essentially start doing the key bindings. So we do the Control L for color of this particular window, and then Control S is to write the file and save the file essentially, and then Control X we bind it to exit. So if you want to exit this particular window, we just type Control X and then it will exit. So the exit corresponds to this .t. And now if you run this demo essentially, like where we go to file and then the top level WM title is t emacs file name and do color.t, and then now we can bring up the emacs. So I will talk about the canvas widget, but we will probably like see the actual example in the next lecture. Okay, so canvas widget is another type of widget which it is used for drawing primitives, and essentially like what this text is doing for words. So it's just an open-ended rectangle where whatever you can draw, and then that drawing is getting captured. So here again for this particular widget there are specific commands, basically add tag, bind, create, delete, detag, find, focus. We'll talk about this also like in greater detail. Get tags, item configure, and move and postscript. We also have like the other widget configuration option, which is close enough, scroll region, X scroll increment, and Y scroll increment. So essentially the canvas can be drawn on. So here we can draw a smiley face with all the various things, and then basically the coloring inside. So in order to create this, we create an oval, basically 3, 3, 200, 200, fill yellow, that's this one essentially, and then outline is black, which is the color of the outline, and then we also have another one 50 50 60 70, which is essentially for the eyes. Each one we create exactly where the location, and then we create an arc which is for the smiley face's mouth. That's also done, and then we create this two squiggly arcs, the tiny arcs, which is the next two. So this way we create this smiley face. Now each of these drawing primitive is an item in the numeric index. So when we create that oval, it returns a number for it, and so the items can be tagged as in the text widget. So we can just say item configure 2 and then tag is yes, tag is eyes, and then same thing eyes. So we tag these two ovals as eyes. And then we can also search items within this canvas widget and using this find closest. So if you give a find closest and give a coordinate, and then basically it returns 2, which is the left eye. So yeah, left eye and right eye. Okay. And then items and tags can also have some bindings. You can say like I'm in .c bind eyes, enter, and then we can say wink, and then how to wink. Or if you say like if you press leave, then it will unwink. So all these kind of things. So I want to end at this point. Essentially, I think, and then next lecture we will take up on the furniture arranger as a program, and how we can design it and how we can execute it using TK. So I think that's pretty much it. We will summarize as we go along, and then thank you once again for listening in. Thanks.